Let's take a look at some problems from section 1.5 homework that reviews how to solve linear equations and inequalities both analytically and graphically. The first few problems I've taken from my math lab. The first one is a 0 of a function f is a number c that satisfies f of c is equal to 0. For example, 4 is a 0 of f of x equals 2x minus 8, since f of 4 is 2 times 4 minus 8, which is equal to 8 minus 8, or 0. We want to use an analytic method to determine the 0 of the linear function f by solving f of x equals 0. So this is just one to find where f of x is equal to 0. In other words, we're going to set 2 times 4x minus 5 plus 6 times 2x plus 8 equal to 0. Clearing parentheses gives us 8x minus 10 plus 12x plus 48 equals 0. When we combine like terms, 8x plus 12x is 20x. Negative 10 plus 48 is 38. That's equal to 0. We can subtract 38 from both sides to get 20x equals negative 38. And finally, divide by 20, so x is negative 38 over 20, which reduces down to negative 19 over 10. Linear equations y1 and y2 have been defined, and the graph of y1 minus y2 is shown. Use the x-intercept method of the graphical solution to solve the equation y1 equals y2, or as your book also calls that, the zero method. So remember that if we have y1 equals y2, that implies that y1 minus y2 is equal to 0. So when we find the 0 of this function y1 minus y2, we have found the solution of the equation y1 equals y2. They're giving you the screen negative 10 to 10 by negative 10 to 10, which just means a standard viewing window. And it looks like this is crossing at the x value of negative 1. So if we had done the 0 on that, we would see that the 0 is at negative 1. And so that means the solution of the equation is x is equal to negative 1. The next problem says, the table shows selected ordered pairs for two linear functions y1 and y2. Use the table to solve the equation y1 equals y2. So what we're trying to find is what x value that has the values of y equal to one another. So in the columns, we're looking for where do the values of y1 and y2 equal, and then look for the x value that corresponds to. If you can see, y1 and y2 are equal when the value of x is equal to 1. So the solution of this equation is x equals 1, or in the solution set notation, we would just put the 1. Be careful here. If you type x equals 1 inside the brackets, it's going to count it wrong. So you just want to put the numerical value inside the set brackets. The next problem is to use the intersection of graphs method to solve this equation for x. This is one that you would really want to use your calculator for to be more precise, so you could actually approximate what the square root of 3 and the square root of 10 are and so on and do it by hand. But if we're going to do the intersection of graphs, remember how we let one side be our input for y1, the other side is the input for y2. Now I've already done that just to save some time so you don't have to see me type all this in, but it is of particular importance to note how I do the radicals. Remember, when you do the square root, which is the second x squared key, it automatically opens up a parentheses. So you have to close the parentheses to end the radical. And that's particularly important when you have the square root of 10x. If you don't close the radical before you type in the x, it's going to think the x is inside the radical. So whenever we graph those, we get this picture. So remember, the intersection shows us what solution we have for that equation. To find the intersection, you're going to do second trace 5 and enter first curve, second curve, and guess, and this is your intersection point. So the x value is the solution of the equation. So to round it to the nearest hundredth, which is what my math lab says to do, it would be 2.39 would be the x value that solves that problem. Okay, now we want to refer to the graph of this linear function to solve the inequality specified in these parts. So remember that to solve a linear inequality, we're looking for the values of x that satisfy the corresponding inequality portion. So it says to find the interval where f of x is greater than 0. F of x is greater than 0 means where y is greater than 0. And we know where y is equal to 0 on the x-axis, so that looks to be like at -3. Y is greater than 0 above the x-axis. Well, that is all values to the right of 3, right? All values to the right, I'm sorry, I said 3, of -3. And so our solution to this is from -3 to infinity. Now, if you had said where f of x is greater than or equal to 0, we would then include the -3. If f of x is less than 0, that's to the values left of -3, so that would be from -infinity to -3. The next problem here, suppose the temperature x miles above the ground is given by this formula T of x equals 50 minus 29x. Determine where the temperature is below 25. Assume the domain of T is between 0 and 6. Answer the following questions. Well, we want to use the intersection of graphs method to estimate where the temperature is below 25. So what we're really trying to do in this problem is we're trying to find where 50 minus 29x is less than 25. Okay. Well, so what I had to do is graph in y1, 50 minus 29x, and y2 I put 25. Now I had to change the window because I know that the y-intercept of y1 is 50, and then it's decreasing by 29 for every value of x. So I just got a picture of that. Our largest value of x that we need to even consider is 6 because we can't go outside of the domain. So at this intersection point is where the temperature is equal to 25. Where is it below? What's below it in this region here, all the way up to the 6. And I should have extended this graph down here so you could see. So I needed to know what values of x does that lie between. Well, I know my highest value of x is 6, right? Because I can't go outside of that. But what's that intersection? So if I do second, trace 5, I get the intersection, which is at 0.86. So the temperature is below 25 when x is between 0.86 and 6. Okay, notice we can include the endpoint of 6 because the temperature is less than 25 at that point included. In these problems, we have two linear functions, y1 and y2, that are graphed, and their point of intersection is indicated. Give the solution set of y1 equals y2. These problems actually came from the textbook exercises. And so we know that y1 is equal to y2 at the point of intersection. So all you need to answer here when it says to give the solution set is just the value of x. So x equals 10 would be the solution to the first one. X equals -2. Okay, and here x is equal to 1. For problems 14 through 16, it says use a graph of y equals y1 minus y2 to solve this equation y1 equals y2. So this is just using the zeros, right? y1 minus y2 equals 0. So if we find the 0 of this function, we have the solution for the equation. Well, the work is already done. All you have to do is read it off. The 0 is the solution of the equation. So -0.83. This problem, where's the 0? It's at 2. So the solution would be 2. The table here shows ordered pairs for two linear functions y1 and y2. Use the table to solve the given equation. So remember, we're talking about what x value makes the y values equal. So in the first problem, what x value makes the y values equal? Well, they're equal here at that -8. Do you see that? Hard for me to highlight it without everything else. So that's for the x value of 4. That yellow didn't show up really good. I was trying to highlight. Okay. We'll do another one. Where's y1 equal to y2 for this problem? As we go through our values, at -17 we see the y values are equal. Where did that occur? When x was a -3. Okay. Now 43 and 44 are a little bit different because they're giving you the y1 minus y2 equals 0, but notice that's the same thing as where y1 equals y2, right? It's the same thing. So whenever we look in our table, y values are the same for x equals 1.5. Okay? And I'll leave the last one there for you to figure out. Now, refer to this graph, and we're going to use the graph to solve the inequalities. So this is where you really have to have that understanding of what you're looking for on the graph. In 71, we're looking for where f of x is greater than 0, or where y is greater than 0, which is where the graph is above the x-axis. So this is why we need to know where it hits the x-axis. It touches the x-axis at 20. Where is it above? To the left or to the right? What is above? To the right. So the answer to part A there would be from 20 to infinity. Where is it below or less than 0? That is to the left of 20, which would be from negative infinity to 20. The last two are the same except for the fact that you would include the endpoint of 20. Okay. And a last problem that I want to work for you is to solve the equation, or inequality rather, analytically. Write the solution set in interval notation. So if we just look at number 78a, we would have 5 minus 3x is less than or equal to 7 plus x. So we can isolate the variable term to one side to get negative 3x is less than or equal to 2 plus x. So then we need to subtract x from both sides to get negative 4x is less than or equal to 2. And here we have to divide by negative 4. So x is greater than or equal to negative 1/2. Remember that when you divide by a negative sign, you've got to reverse that inequality. So analytically, we know the solution to be negative 1/2 to infinity. Now to graph that, you could do the intersection method or the zero method and find that graphically. But then the other part, it says we should know, well, if it's less than or equal to 0 for these values, it's going to be greater, I'm sorry, not less than or equal to 0. If it's less than or equal to 7 plus x for these values, it's going to be greater than for the opposite values. So part B is going to be everything to the left of negative 1/2, which would be negative infinity to negative 1/2 with a parentheses. Okay, so that concludes some problems from section 1.5. Please don't hesitate to contact me if you have any questions. Thank you.